Hello, my dear students. Welcome to Unacademy. This is your Bhanu sir. Sindhura, good evening. Nageshwar Rao, Nageshwar Reddy, good evening. Am I audible to you? Okay. Comment on my voice. Is it audible to you? Sindhu, వినిపిస్తుందా? Nageshwar, is my voice clear? Okay, let's wait 2 minutes. Then after we will start the session. Is it clear? Am I audible to you? Nageshwar, say yes or no. Okay, very good, Sindhu. Yes, I'm fine. How are you? Josna, yes sir. Okay, very good. Very good. Good evening. AK, you have a question. Very good. After 90 degrees of flux induced EMF induced in the both primary and secondary coil. Is it correct? Yes, AK, it's correct. Initially, flux produced in the transformer after the supply given to the transformer. So after 90 degrees time delay, EMF induced in the primary winding and secondary winding simultaneously. Okay, the EMF, the phase displacement between the flux and induced EMF is equal to 90 degrees, and phase displacement between the applied voltage and flux is equal to 90 degrees. Similarly, phase displacement between the supply voltage and induced EMF equal to 180 degrees. Okay, yesterday we had discussed this part. Okay, are you clear now, AK? Kuchinama question. Ashavardhan, good evening. So let's wait 2 minutes, then we will start the session. So let's wait our friends. Let them come. Very good. Yes, sir. It's clear. Good. Bharat, good evening. Okay. For new learners, this is Bhanu Prakash, expert in GATE and ESE coaching. I did MTech from NIT Kurukshetra. I have 10 years of teaching experience especially in the GATE field. I train many students for different competitive exams like GATE, ESE, Transco, Genco, all competitive exams in the triple E stream. Have taken subjects of electrical machines and power electronics. Okay, I deal these two subjects, electrical machines and power electronics. Okay, I already mentioned. Okay, here there are two type of the live classes. Okay, in Unacademy, one is a the YouTube live classes. Okay, YouTube live classes, and these classes are absolutely free. No need to pay single rupee to access these classes. Okay, and second one is a the learning Unacademy, the learning of. Okay, this is a Unacademy learning of the live classes. Okay, this is so to access these classes. Here also we have a two type of classes. One is the special classes. Okay, the special classes, and second one is that is a plus classes are. Okay, special classes are free of cost. Okay, just to download an academy learning app, you can access these special classes. One is the plus classes. To access these classes, you have to take the subscription. So there are the two types of subscription. One is a plus subscription and second one is iconic subscription. What are the benefits of plus subscription? You get live classes from the top educators of the country. Okay, and second one, you can get structural schedule, so we can plan for 3 months, 6 months, 12 months or 2 years. You can plan as your wish. That is the structural schedule. And second third one is a unlimited practice question. You can't expect okay how many questions are there to practice, so that is the unlimited practice question. And final one is a test series. Okay, nowadays for any competitive exams, okay, so test series plays very important role to crack that exam. Okay, got my point. So here to get so this test series, you must take plus subscription. Okay, and one more subscription is a iconic subscription. So here, in addition to these benefits, there are some other benefits if you take iconic subscription, such as personal coach, study planner, and third one is expert guidance, and also ESE mains question and answers. Okay, you can get all practice questions, and also for every question you will get the solutions. That is the benefits of the plus subscription and iconic subscription. What about the fee structure for the plus subscription and also iconic subscription? So for the plus subscription, this is for the 6 months, 12 months and also 24 months. Suppose if you prefer 12 months, the fee structure is the 25,000 rupees. Got it my point? The fee structure is a 25,000 rupees. Suppose if we use my code, so that is the BPC10. Okay, this is my referral code. So if you use this code, you can get 10% discount. So by using this discount, you have to pay 22,500 rupees only. This is about the 1 year subscription. That is a for plus subscription here. And in order to get iconic subscription, and this is the 12 months, the fee structure is a the 45,000 rupees. Okay, got it fine. So if you use my code, that is the BPC10, so we will get 10% discounts. After the discount, you have to pay only 40,500 rupees. This is about the fee structure for plus subscription as well as the iconic subscription here. And what are the payments methods are there? So you can pay your direct amount, also you can pay your EMI option, total amount or EMI options. So by using the Bajaj card and some other credit cards, HDFC, ICICI, SBI, Axis, that's the Kotak Bank. Okay, all EMI cards are accepted. And for 3 months EMI, So what is the per month fee here? That is a 7,500 rupees per month. For 6 months EMI, how much amount of per that is 3,750 rupees. For 9 months EMI, per month fees are 2,500 rupees. For 12 months EMI, what is the per month fee? That is 1,875 rupees. Okay. So if you use my code, that is BPC10, this is my referral code. So this code you can use for any competitive exams like GATE, ESE, other banks, railways, any type of exams. You can use this code. If you want to take any type of the coaching, so you can use this code, you will get 10% discount. Okay, and what after the discounts we have to pay only 22,500 rupees. Got it? Fine. And personally I want to share one thing. This month the fee structure for the plus subscription is after the discounts it is at 22,500 rupees. సో ఈ మంత్ లో ఫీ హైక్ అయ్యే ఛాన్సెస్ 100% ఉన్నాయి. సో ఇట్ మే బి డబుల్ ఆర్ ఎనీ అదర్ అమౌంట్ ఆల్సో దేర్. సో దట్స్ వై ఇఫ్ యూ వాంట్ టు టేక్ సబ్స్క్రిప్షన్, టేక్ ఇట్ యాజ్ ఎర్లీ యాజ్ పాసిబుల్. Otherwise it may be the fee hike, so suppose it may be double or any other amount, so that's why it is difficult for you. So don't be late. Okay, sometime late is also not good for our life. So that's why if you want to really take it and really preparing for competitive exams, take it as early as possible. Okay, మీరు తర్వాత తీసుకోవాలనుకున్నా కూడా ఫీ హైక్ అయ్యే ఛాన్స్ ఉంటుంది. ఇప్పుడు నువ్వు 22,500 ఉన్నాయి కదా, సో ఇయర్ చాలా డిమాండ్ ఉంది. ఒక చాలా అంటే చాలా డిమాండ్ ఉండదు కాబట్టి ఈ హైక్ చేసే ఛాన్సెస్ ఎక్కువ ఉంటుంది. ఈ మంత్ లోనే హైక్ అయ్యే ఛాన్స్ ఉంటుంది. మీకు ఏమన్నా కంపల్సరీ తీసుకోవాలని మంచిగా నేర్చుకోవాలి సబ్జెక్ట్ అనుకుంటే మాత్రం తొందరగా తీసుకోండి. ఒక మళ్ళీ ఆలోచించకుండా. ఓకే, గట్ ఇన్ మై పాయింట్ వాట్ ఐఎమ్ టెలింగ్. ఆల్ ఆఫ్ యూ క్లియర్? భారత్, ఆర్ యూ క్లియర్ అబౌట్ ఆల్ దీస్ థింగ్స్? ఓకే, మీరు సబ్స్క్రిప్షన్ తీసుకోవాలనుకుంటే యాజ్ ఎర్లీ యాజ్ పాసిబుల్ తీసుకోండి. నేను తర్వాత చూద్దాం, నెక్స్ట్ మంత్ చూద్దాం అంటే ఈ అమౌంట్ డబల్ అయ్యే ఛాన్సెస్ చాలా ఎక్కువ ఉంది. మీరు అప్పుడు తీసుకుంటే వేస్ట్ అవుతుంది. మీరు ఇప్పుడే ఒకవేళ 2 months ఫీ ఒకటేసారి తీసుకున్నా అనుకోండి, మీరు బీటెక్ అయిపోయే లోపు మీకు జాబ్ వచ్చేస్తుంది. అంటే ఒక పర్ఫెక్ట్ ప్లాన్ ప్రకారం చేసుకోండి. సపోజ్ మీరు థర్డ్ ఇయర్ ఉన్నారు అనుకోండి, థర్డ్ ఇయర్ ఉంటే నీకు 2 yearsలో నీకు జాబ్ కావాలి అంటే ఫైనల్ ఇయర్ అయిపోయిన తర్వాత నెక్స్ట్ కంప్లీట్ అయిపోగానే నాకు జాబ్ కావాలన్నప్పుడు 2 years సబ్స్క్రిప్షన్ తీసుకొని నువ్వు కంప్లీట్ ప్లాన్ ప్రకారం, ఎట్లాగో స్ట్రక్చరల్ షెడ్యూల్ ఇస్తారు కాబట్టి ప్లాన్ ప్రకారం మీరు చదివారు అనుకోండి, 2 years తర్వాత వరకు నీ దగ్గర ఒక యాక్చువల్లీ ఒక బ్యాక్ సపోర్ట్ ఉంటుంది అనమాట. ఈ సబ్స్క్రిప్షన్ అనేది నువ్వు ఎప్పుడు కావాలన్నా కోచింగ్ ఏ వీడియోస్ కావాలన్నా అవన్నీ నువ్వు వినొచ్చు. సో అప్పుడు నీకేమవుతుంది, బ్యాక్ ఎండ్ లో నీకు సబ్స్క్రిప్షన్ ఉంటుంది. నువ్వు చదువుకున్నావు అనుకో, నీకు బీటెక్ అయిపోయే లోపు నీకు జాబ్ వస్తుంది. ఓకే, నువ్వు ఒక్కనివి ప్రిపేర్ అవుతూ నువ్వు ఒక్కనే ప్లాన్ చేసుకుంటూ ఉంటే కొంచెం నీకు వస్తుంది, ర్యాంక్ వస్తుంది. కానీ ఇట్ టేక్స్ మోర్ టైమ్, ఇట్స్ నాట్ పాసిబుల్. ఓకే, అలా కాకుండా నీకు మేమందరం సపోర్ట్ చేస్తాం కాబట్టి, సో నువ్వు ఒకవేళ నీకు చాయిస్ ఉంటే కంపల్సరీ యాజ్ ఎర్లీ యాజ్ పాసిబుల్ తీసుకోండి. నువ్వు తర్వాత తీసుకుందాం నెక్స్ట్ మంత్ లేకపోతే 3 months తర్వాత ఆలోచించుకుంటూ ఉంటే ఫీ హైక్ అవుతుంది కదా, డబుల్ అయింది అనుకోండి, 50,000 అయింది, అది మీకు బర్డెన్ అవుతుంది. అందుకని నేను చెప్తున్నాను, మీకు ఛాన్స్ ఉంటే తొందరగా తీసుకోండి. ఓకే, గట్ ఇట్ మై పాయింట్. ఆల్ ఆఫ్ యూ. ఓకే, this is my code. If you want to, suppose if you use this code, that is BPC10, so you will get 10% discount for any year. Suppose if you want to take 1 year subscription, so you can get 10% discount. If you want to take 2 year subscription, you can get to the 10% discount. For the 2 years it is a 30,000 rupees. Okay, and if you by using this code you will get the coaching for that only 27,000 rupees. అలా 2 months మీరు ప్లాన్ చేసుకుంటే, సో 2 years తర్వాత నువ్వు కంపల్సరీ ఎక్కడో ఒక దగ్గర సెట్ అవుతావు. నీకు ఏ జాబ్ అయినా సరే, నీకు ఏమైతే డ్రీమ్ ఉందో అది అచీవ్ అవుతావు. సో ఇట్స్ మై పర్సనల్ సజెషన్ ఫర్ యూ. ఓకే, టేక్ ఇట్. ఓకే, యాజ్ ఎర్లీ యాజ్ పాసిబుల్. థ్యాంక్ యూ. ఆర్ యూ క్లియర్? శ్యామ్ సుందర్, భరత్, గుడ్ ఈవినింగ్. సారీ సార్, టైమ్ అడ్జస్ట్మెంట్ వల్ల అటెండ్ కాలేకపోయినా ఈ రోజు నుండి ఐ విల్ బి అటెండింగ్. గుడ్ శ్యామ్ సుందర్, ఐఎమ్ ఆల్సో వెయిటింగ్ ఫర్ యూ. వెర్ ఈస్ శ్యామ్ సుందర్? What happened to Shyam Sundar? Yesterday also I saw so many messages. Mohan, Nageshwar, all of you clear about all these things? Let's move our actual subject discussion. Okay, mention thumbs up symbol, all of you, if you got it. Everybody, be active in the group. Yes. Okay, come on, pass. Give past replays. Very good, very good. అలా ఉండాలా, పాస్ట్ రిప్లై ఉండాలా. కమానికే జోష్నా, శ్యామ్ సుందర్, భార్గవ్, హర్షవర్ధన్, వెరీ గుడ్. సింధు, దినేష్, వెరీ వెల్. ఓకే, so previous class we had discussed about how do we derive the EMF equation of the transformers. Okay, so we know that where the V1 is a supply voltage, V is equal to Vm sin omega t. Okay, omega t. And here transformer is a pure inductive nature, so that magnetizing current lags the applied voltage by 90 degrees here. So that is equal to Im the sin omega t minus 90 degrees here. Got it? After 90 degrees time delay, the current passes through the primary winding. That current is known as a magnetizing current. So for our convenience, this equation you can write. So we can write another way also. So where V1 is equal to Vm sin omega t. Okay, sin omega t. So plus, so Vm sin omega t plus pi by 2. So this equation will become, so it is a leading. So here Inu is equal to Im sin omega t. Both are correct. Okay. Suppose if we take V1 is equal to Vm sin omega t, Inu will become Im sin omega t minus pi. So in this case, this is considered as a reference. Okay. And here this will be considered as omega t minus 0. So that is nothing but 0 reference. So reference. So applied voltage leads the magnetizing current by 90 degrees. Here magnetizing current lags the applied voltage by 90 degrees here. So after that we got flux is equal to phi 1 is equal to, so that is a phi maximum sin omega t. Okay, this is the flux produced in the primary winding. How do we get EMF equations? Instantaneous induced EMF in the primary winding. E1 maximum is equal to the sin, that is the E1 equal to E1 maximum sin, that is a omega t minus pi by 2. Okay, similarly EMF induced in the secondary winding, E2 maximum is equal to E2 maximum the sin the omega t minus pi by 2. Okay, this is the two induced EMF are the lags the flux by 90 degrees. E1 lags the flux by 90 degrees. Similarly E2 also lags the flux by 9. So what is the phase displacement? These two here, applied voltage and induced EMF. So it is a plus 90 degrees and this one is a minus 90 degrees. So that phase, the displacement between applied voltage and induced EMF equal to 180 degrees here. Got it? So this E1 maximum, how do we get RMS value? E1 RMS is equal to, so E1 maximum the divided by root 2. So by simplification you will get 4.44 phi maximum Fn1. So this is the primary induced EMF in the primary here, in the transformer. Similarly, secondary induced EMF E to RMS value, so that is equal to, so E to a maximum value divided by root 2. Always RMS value equal to maximum value by root 2. So by simplification, you will get 4.445 maximum frequency Fn to N. So this is the EMF equation in the primary winding, and this one is the EMF equation in the secondary winding of transformer. So all this one we had discussed in the previous class. So now we can say that directly. What is the relation between magnetizing current and applied voltage? I nu lags the flux by 90 degrees. What is the relation between flux and primary induced EMF? So here E1, so that is the E1 lags the flux pi 1 by. Okay, this is the first conclusion. Yesterday I mentioned that E1 lags flux pi 1 by 90 degrees. Got it? Now similarly E2 lags, okay, phi 2, so by 90 degrees. Okay, this is so we have discussed. And one more relation, the here magnetized transformer is a pure inductive nature, so that magnetizing current lags the applied voltage by 90 degrees. Got it? So all these points we have discussed in the previous class. Okay, all of it clear about all these things, everyone? Are you clear? Have you got it? Have you got it? Okay. Yes. Good, Josna. Yes, sir. AKS mention everyone. Very good. So today we will discuss some interesting topic and very more important for competitive exams. So I'm sure this topic is a very useful if you write any competitive exams also. So here derivation part you can get from any textbook also. There is no doubt at all. But behind the derivation, what are the possible questions from the EMF equation of the transformer? So that we will discuss today. Okay, all of it clear? So first one of the derivation or one of the question here, the first one is, so what are the observations from the EMF equation of the transformers? Observations from the EMF equation means, so that all possible question from the EMF equation of the transformers. Got it? So first observation, EMF equation of the transformer in terms of the maximum flux density. Okay, in terms of maximum flux density and area of cross section of the transformer core. So let assume here, so B maximum, B suffix M. So B maximum is a maximum flux density of, okay, flux, so density of, okay, density of transformer core. Okay, so what are the units for this case? It can measured in the Webers per meter square. Okay, Webers per meter. And here is flux density B maximum is equal to B maximum divided by phi maximum by area of net cross sectional area of the transformer core. So now this is the measured in Webers per meter square or Tesla. Okay, this is the R Tesla here. So from this equation, and here also we have a question, that is area of the cross section. So let us assume here N, that is a N here, AN is a the net cross sectional. Okay, this is a net, the cross sectional area of transformer core. Okay, net cross sectional area of the transformer core. So previous class I mentioned that there are the two types of the area of cross section. One is a gross cross sectional area of the transformer core, and second one is net cross sectional area of the transformer core. So what is the mean by area, net cross sectional area here? The area occupied by, okay, area occupied by magnetic material only is called the net cross sectional area of the transformer core. So why not grass crossing? Why not grass cross sectional area used in the in this equation here? What is the reason? So here flux flows in this case here, the flux flows in magnetic material. The flux flows in magnetic material only. Magnetic material only here. So but not, okay, but not insulating materials. Okay, insulating material, so that, okay, an is considered, okay, an is considered for all calculations of, okay, this is for all calculations of transformers. Got it point? So why not as here EMF induces in the transformer directly proportional to the flux. So this flux flows in the magnetic material but not in the insulating material. So that's why which area we have to be consider? Is it net cross sectional area or grass cross sectional area? Net cross sectional area to be considered for all calculations of the transformer. Okay, what is the reason? So this is a, so here it flows, flux flows in the, here this is the only magnetic material but not in the insulating material. Okay, so let us assume this is the equation 1. Okay, so from this equation, okay, okay, from this equation 1 you can write, so otherwise I will repeat here. So this equation you can write, so here phi maximum is equal to, phi maximum is equal to, so B maximum AN. Okay, let us assume this is the equation 1. So now substitute, okay, now substitute, by substituting, okay, by substituting phi maximum, substituting phi maximum in EMF equations. Okay, EMF equations here. So what is the EMF equation? E1 is equal to 4.44 phi maximum Fn1, clear? And E2 is equal to 4.44 phi maximum the Fn2 here. So instead of maximum value of the flux, so here we have substituted, by substituting pi maximum in the EMF equation, we get E1 is equal to 4.44. Okay, 4.44. So B maximum AN Fn1. Okay. Similarly, EMF induced in the secondary winding, E2 is equal to 4.44 B maximum AN Fn2. Okay, Fn2 here. So this is the EMF equation of the transformer in terms of the flux density and also net cross sectional area of the transformer core. So where in this case this F is a supply frequency. Okay, this is the supply frequency in this case, where N1 is a number of tons. Okay, here is N1 in the sense number of tons of primary winding. Got it point? The number of tons of the primary winding. Where N2 is a number of tons of secondary winding of transformer. So what are the possible questions from this equation? Sometimes EMF and flux density, EMF, flux density, frequency, number of tons are given. Find out the net cross sectional area of the or area of transformer core. This is the one possibility of the question. Now similarly, and sometimes here B, here AN, frequency, number of tons and induced EMFs are given in the any question. Find out maximum value of the flux density of the transformer core. So this is also another type of possibility question. Okay, from this equation, okay, we have there are three more possibilities. Some other terms here all are mentioned. Find out induced EMF in the primary winding or induced EMF in the secondary winding of transformers. Got it? So are you clear now? Okay, mention in the chat box. Then we will move another observation. Very important. These observations are very important for all competitive exams. You can't get any textbooks these observations. Okay, good. Akshay, good evening, sir. I did not listen previous 4 classes. Okay, due to signal problem. Can I continue from now? You can continue, Akshay, no problem. Whenever you have a signal and you have a net, then you can listen other classes. Okay, that YouTube offline classes are available in the YouTube. So you can continue. Okay, now you can continue the class. No problem. You can understand everything also. Shamsundar asked one question. Sir, as frequency increases, area required will be reduced in 1 by interview. It's a question. Yes, that's question. That question you can solve by using these observations. Shamsundar, that is the right question, but that question we will solve in this class only. From onwards, you can answer that question confidently. I'm sure. Okay. So next observation, that is the EMF per turns ratio of the transformer. So what is the EMF per turns ratio of the transformer, and what is the relation between the EMF per turns ratio in primary winding and EMF per turns ratio in secondary winding of transformer? Okay, this type of question. So from above observation, from this case, from observation 1, from observations 1, so we get, okay, see here all of you, so from observation 1, so we get that is a E1 is equal to 4.44, the B maximum AN FN1. Okay, so this equation you can write. Okay, this equation, so that is a E1 by N1. Okay, E1 by N1, so that is equal to 4.44 B maximum ANF. Okay, ANF. Similarly, in secondary winding, so what is the E2 value in terms of the flux density and net cross section area? The E2 is equal to 4.44 B maximum ANF N2. Okay, all of you clear now? So now from this equation you can write E2 divided by N2, so that is equal to 4.44 B maximum ANF. Okay, frequency F here. So now by using these two equations, okay, here see, so this equation, okay, it is the equation 1. Okay, similarly, and this is a equation 2 here. So therefore by using these two equation in this observation, so then what we observed here, E1 by N1 is equal to, therefore E1 by N1, okay, is equal to, so E2 by N2, so that is equal to, okay, here 4.44 B maximum ANF. Okay, ANF here. So therefore what we conclude from this equation, EMF per turns ratio in primary winding is equal to EMF per turns ratio in secondary winding of transformers. So got it point? So that is EMF, okay, EMF per turns ratio. Okay, this is the turns ratio in primary winding. Okay, that is in the primary winding. So that equal to EMF per turns ratio. Okay, this is so turns ratio in secondary winding of transformer. So very important relation. Okay, to answer these questions here. So always EMF per turns ratio in primary winding equal to EMF per turns ratio in secondary winding of transformers. Okay, all of it clear now about second observation. So this is also we can obtain from this EMF equation of the transformer. Okay. Bargouts are transformer taps. Tappings are provided on HV winding of the transformer. Okay. To access, for example, so this is a LV winding of transformer, and this one is the HV winding of transformer here. Taps means suppose it is a 100 volts. Suppose this is a 400 volts transformer here. But we required only we have a transformer of the 100 upon. The requirement is so that is a 100 upon 200 volts transformer is required. So that time if there is a tappings on the HV side, so then what will happen? So it is a 50% of the tappings. So this is another terminal. So that's why you can connect the load between these two so that you can get required transformer like 100 by 200 volts. So tappings are provided on HV windings to access the required output voltage. Okay, required output voltage from the given transformer. Got it, Bharat? That is the meaning of tapping. We will discuss very clear whenever we have a discussion about the tapping of the transformer. Bharat, I will tell you. Just give me 2 minutes. I will answer that question. How frequency is related to area of transformer? All are waiting for that question, but that question I will discuss in this class only. Okay? Don't worry, that question I will discuss here. Just wait some time. Now tell me about this observation. All of it clear now? మీకు డెరివేషన్ పార్ట్ ఏ టెక్స్ట్ బుక్ లో అయినా ఉంటుంది. there is no doubt at all. బట్ బిహైండ్ ద డెరివేషన్ అనేది కాంపిటేటివ్ ఎగ్జామ్స్ లో చాలా ఇంపార్టెంట్. ఓకే, దట్ వీఆర్ డిస్కసింగ్ హియర్. Okay, next. Third observation is a transformation ratio of transformer. Okay, so this transformation ratio is denoted by, okay, it is denoted by so capital K. Okay, capital K. This is the transformation ratio. So how do we get this transformation ratio? This is also can be obtained from the EMF equation of the transformer. So how do we obtain? So from observation, okay, so here see, so from the observation 2, okay, observation 2, so we get, so that is a EMF per turns ratio in the primary winding is equal to EMF per turns ratio in the secondary winding of transformer. So that is that means E1 by N1, okay, equal to, that is a E2 by N2. So this is EMF per turns ratio in the primary winding equal to EMF per turns ratio in the secondary winding. So by rearranging above equation, so that is rearranging the above equation, so we get, okay, we get the, So N2 by N1. Okay, here is N2 by N1 equal to E2 by E1. So this is nothing but, okay, this is a transformation ratio K here. So that is the ratio of it is nothing but K here. So it is the ratio of, okay, ratio of, so that is a ratio of number of turns. Okay, here number of turns. So that is the number of turns in primary winding. That is the in primary winding to number of the turns. Okay, number of turns in secondary winding of transformer. This is a secondary winding of the transformers. Got it point? So per year sometimes we have a question like what is the mean by, that is a, what is the mean by turns ratio. So turns ratio is denoted by, okay, this is the turns ratio. So it is denoted by small a, okay. The transformation ratio denoted by capital K here and turns ratio is denoted by small a. So it is a reciprocal of the transformation ratio, that is a 1 by K. So 1 by K is equal to how much? It is a N1 by N2 and that equal to E1 by E2N. This is the transformation ratio of the transformer. Suppose in the transformer, let us take one example. So we have a transformer like the ratings are given. This is a single phase. So that is a 50 hertz transformer and voltage rating of the transformer is 400 upon the 200 volts transformers here. So this voltage rating mention on the nameplate details. Okay, always voltage rating mention on the nameplate details is a primary induced EMF E1 to the secondary induced EMF E1 by E2 only, but not the supply voltage and the secondary terminal voltage. It's always E1 by E2 but not E2 by E1. Suppose if you want to find out what is the transformation ratio here, so that transformation ratio K is equal to, so what is the formula to get the K here? E2 by E1. So therefore E2 is equal to 200. So divided by 400, it is equal to 1 by 2. So this is a the transformation ratio of the transformer. So these are very useful to solve the problems. Always EMF induced in the primary winding is a, here voltage rating mentioned on the nameplate details of the transformer is primary induced EMF to secondary induced EMF. That means E1 by E2 only. Got it point? Okay. All of it clear? Yes, K in the sense turns in the secondary winding to primary winding. Okay, very good. Turns in the secondary winding to primary winding. So if any voltage rating is mentioned on the nameplate device, how do we find out A here? The A is the, this is the K is equal to E2 by E1. That is a 200 by 400. That is equal to 1 by 2. And that is a the 1 by 2 is equal to 0.5. This is the transformation ratio of transformer. Okay, this is a third observation you can obtain from the EMF equation of transformer. Okay, all of it clear? All of you got it about this transformation ratio? Okay, very good. So now let us discuss about, Okay, this is the secondary turns, right? Okay, here definition point of view, turns ratio. Okay, ratio of number of turns in the secondary winding to primary winding, right? That's correct. Secondary winding to the number of turns in the right, Shamsundar, that's correct. What is the use of it? Mohan asked the question, what is the need of this K? So to transfer the resistance and reactance parameter from one side to another side, or to transfer the impedance parameter from one side to another side of the transformer, or any parameter. Suppose if you want to get equivalent circuit, refer to the primary side. So this is the K is a very useful. That means without transformation ratio, the calculation part is very difficult. Mohan, got it? The transformation ratio is the ratio of number of turns in the secondary winding to number of turns in the primary winding of transformer. That is N2 by N1 equal to E2 by E1, that is equal to K. All of you got it? About third observation. Yes, reference of the circuit to the one circuit. Referring. We will discuss about equivalent circuit, all these K, all these points. Mohan? Okay. So our most weighted question, that is the size of the transformer, okay, size of the transformer and frequency of the transformer. This is the observation 4. Okay, so this is a very important question in the interviews and also competitive exams. What is the relation between size of the transformer and frequency of the transformer? Okay, and this relation also we can obtain from the EMF equation of the transformer. So listen, so we know that, okay, we know EMF per turns ratio, okay, that is E1 by N1 is equal to, okay, N1 equal to, so it is a E2 by N2, so that equal to 4.44 B maximum ANF. Okay, B maximum ANF values here. So EMF per turns ratio is constant from the primary winding to secondary winding of transformer. So here B maximum is, okay, it is a B maximum is some finite value. Okay, this is the finite value here. So it is equal to 0.9 Tesla per silicon steel materials here. Okay, this is the some finite value per some, it depends on the that is the nature of the magnetic materials here. So this one is the size of the transformer, right? This is the size of the transformer and this one is the frequency of the transformer here. So here if the size of the transformer, see here, if size of the transformer the increases, okay, size of the transformer increases, okay, operating frequency of the transformer should be decreased to maintain this ratio, okay, this ratio constant, okay, this ratio constant here. So I repeat once again, see, so during the designing of the transformer, so we can change the size during the designing or during the manufacturing of the transformer. So therefore that is a during designing of transformer. So that is a, if size of the transformer, okay, if AN the increases, okay, AN increases, so then the frequency of the transformer, that is the operating frequency of the transformer, should be decreased to maintain, okay, this is the to maintain VMF per turns ratio. Okay, EMF. So per turns ratio is constant. Okay, is constant from primary to this is the from primary to the secondary side of the primary to secondary side of transformers. Okay, got it, fine. So now what is the exact relation? One increases, other one decrease. And in the reverse manner, if size of the transformer decreases, operating frequency of the transformer should be increased to maintain the EMF per turns ratio constant from primary winding to secondary winding of transformers. Got it? So therefore you can write, so here AN is inversely proportional to the frequency of the transformers. What is the mean by AN? It is the size of the transformer core, net cross sectional area of the transformer core. Therefore you can write, so that is the size of transformer is directly is inversely proportional to the frequency of, okay, it is a frequency of transformer. So this is a thus the relation between the frequency and size of the transformers. Got it? So during the designing of the transformer, if AN increases, okay, then operating frequency should be decreased to maintain V by F turns ratio constant from primary winding to the secondary winding of transformers. So got it point? All of it clear? So therefore size of the transformer is inversely proportional to frequency of the transformers. Okay. All of you clear now about the relation between size of the transformer and frequency? Yes, that is a K is the designing parameter. K is equal to N2 by N1, E2 by E1. So we don't know about the current. Based on the current, we will discuss later. So these are only number of turns and induced EMFs. So when current parameter comes into our discussion, that I will define the later about the K. Raju, okay. Any other doubt about this? Shamsundar sir BH కారు అయిపోయిందా లాస్ట్? నో ఏం కాలేదు, ఓన్లీ కన్స్ట్రక్షన్ డీటెయిల్స్ చెప్పాను, ఆపరేటింగ్ ప్రిన్సిపల్, నెక్స్ట్ ఫీచర్స్ అండ్ డెఫినేషన్ చెప్పాను. మీకు ఒకసారి డౌట్ ఉంటే నా ప్లేలిస్ట్లో వీడియోస్ ఉన్నాయి, ఒక ఆల్ వీడియోస్ ఉన్నాయి ఫస్ట్ క్లాస్ నుంచి ఇప్పటివరకు 8 లెక్చర్స్ అయ్యాయి. మీరు ఆ క్లాసెస్ మళ్ళీ రిపీట్గా మీరు వినొచ్చు, మీకు ఎప్పుడు అవి అవైలబుల్గా ఉంటాయి. If you have any doubt, you can ask, you can listen, and also you can ask me anytime. దినేష్ సార్, ఏరియా డిక్రీజ్ చేస్తే మరి వైండింగ్ కష్టం అయిపోద్ది కదా సార్? ఏరియా డిక్రీజ్ చేస్తే అనేది నువ్వు ఏరియా అంటే ఏమనుకుంటున్నావు? ఇది ఏరియా అనుకుంటున్నావు కదా, ఇలా దిస్ ఇస్ ద ఏరియా లెంత్, ఇది లెంత్ అండ్ ఇది బెడ్త్ అని ఇది ఏరియా అనుకుంటున్నావా? సో అలా కాదు కదా. ట్రాన్స్ఫార్మర్స్ లో ఏరియా ఆఫ్ క్రాస్ సెక్షన్ అనేది నువ్వు ట్రాన్స్ఫార్మర్ ఇలా తీసుకుంటే, సో ఇట్ ఈస్ అ వన్ కోర్ అండ్ ఇట్ ఈస్ అ లింబ్ ఆఫ్ ద ట్రాన్స్ఫార్మర్, రైట్? ద టూ లింబ్స్ హియర్, అండ్ దిస్ ఇస్ ఏ ద డిజైన్డ్ లైక్, ఓకే, ఇది కదా ఏరియా ఆఫ్ క్రాస్ సెక్షన్. అంటే నువ్వు ఈ లెంత్ బెడ్త్ ఇలా క్యాలిక్యులేట్ చేయొద్దు, ఇది ఏరియా కాదు. సో ఇది దిస్ ఇస్ ద కంప్లీట్ లెంత్ ఆఫ్ ద కోర్, ఒక మీన్ లెంత్ ఆఫ్ ద కోర్. ఏరియా ఆఫ్ క్రాస్ సెక్షన్ అనేది ఇది ఏరియా ఆఫ్ క్రాస్ సెక్షన్, ఓకే, ఇది ఏరియా ఆఫ్ క్రాస్ సెక్షన్. నీకు వైండింగ్ ఎందుకు ప్రాబ్లం అవుతుంది? నువ్వు ఏరియా ఆఫ్ క్రాస్ సెక్షన్ చేసినప్పుడు నీకు నెంబర్ ఆఫ్ టర్న్స్ అనేవి డిక్రీజ్ ఇంక్రీజ్ అవుతుంటాయి, కానీ ఈఎంఎఫ్ పర్ టర్న్స్ రేషియో వీ హ్యావ్ టు మెయింటైన్ కాన్స్టాంట్. దట్స్ వై వి ఇఫ్ ద ఏరియా ఈజ్ ఇంక్రీజెస్, ఇవన్నీ డిజైన్ దగ్గర చేస్తాం కదా, ఏరియా ఇంక్రీజ్ చేస్తే నువ్వు ఆపరేట్ అయ్యే ఫ్రీక్వెన్సీ ఎక్కువ ఉండాలి. ఓకే, దిస్ is the area of cross section. area of cross section, not this length and width. Okay, it's not calculated, it's not correct. Dinesh, are you got it, my point? Okay, now what about the ear? This is the mean length. Okay, mean length of complete, this is nothing but mean length of the core. So therefore, volume of the core is equal to volume of core. So that is a mean length multiplied by net cross sectional area. Like, okay, winding ఎలాంటి ప్రాబ్లం లేదు. శ్యామ్ సుందర్ లేలే అది కరెక్ట్ చేశాం. మళ్ళీ ప్లేలిస్ట్ లో ఈఎంఎఫ్ ఈక్వేషన్ పెండింగ్ అని ఉంది కదా, అది కరెక్ట్ చేశారు. మీరు మళ్ళీ ఒకసారి చెక్ చేయండి శ్యామ్ సుందర్. నువ్వు ప్లేలిస్ట్ లో ఉంది, దాని వీడియో కరెక్ట్ చేశాము. మళ్ళీ ఒకసారి చెక్ చేయండి, మీకు ప్లేలిస్ట్ అవైలబుల్ ఉంది, ఇప్పుడైనా కూడా ఉంది. ఆల్ 8 వీడియోస్ ఎలక్ట్రికల్ మిషన్స్ ఉన్నాయి, ప్లేలిస్ట్ లో ఉన్నాయి, మీరు చెక్ చేసుకోవచ్చు. మీకు ఎప్పుడు ఉంటాయి అవి, మీకు ఏం డౌట్ ఉన్నా మీరు రిపీటెడ్ గా చూడొచ్చు. ఓకే, all of you clear now? What is the relation between size of the transformer and frequency? Size of the transformer inversely proportional to the frequency. Now there is a question here. Can you answer this question, all of you? Can you answer this question? So read the question. Which transformer is small in size? Okay, which transformer is small in size? What is the answer? Very good. All are given correct one. That is the transformer which has high frequency. The transformer. So which transformer small in size here? The transformer which has high frequency is small in size. Small in size. Okay, so compare here, this is the 30 hertz, 40 hertz, 60 hertz, so that it is a 60 hertz. So this transformer is the small in size the here as compared to other frequency transformers. Okay, that I will conclude now. Suppose Indian operating in India. So this is the in India. So here is India. Here the operating frequency of the grid. Okay, complete operating the frequency of electrical system. So that is a 60 hertz. Okay, that is equal to the 50 hertz. So that is in India. Suppose in USA. Okay, USA. So what is the operating frequency of electrical system? That is equal to the 60 hertz. So that means here frequency, how do we decide this frequency here? So from this alternator, F is equal to Pn by 120. So here the speed here, turbine speed depends on the number of poles and also turbine speed. Our complete turbines in the power stations is to have the power to generate the power at a frequency of the 50 hertz. But in the USA, operating electrical frequency the 60 hertz. So that's why here India made transformer. Okay, or USA made transformer. Sometimes we have a question in the interviews. USA made transformer is small in size. Okay, this is the small, the in size as compared to the India made transformers. Okay, this is also one more conclusions here. Okay, USA made transformers are small. USA made transformer is small in size as compared to India made transformers. Got it point? What is the reason? USA electrical operating frequency is 60 Hz and India electrical operating frequency is 50 Hz. I will tell you one more example. Okay, here the in India are electrical operating frequency. In India, electrical operating frequency. Okay, this is the operating. The frequency is equal to. So as I mentioned earlier, so that is equal to electrical operating frequency the 50 Hz. Okay, and what about electronic operating frequency? Okay, electronic. Okay, electronic operating frequency. How much it is? So that electronic operating frequency is the in kilohertz. Okay, this is the kilohertz and megahertz like so on. Okay, this is electronic operating frequency and this one is the electrical operating frequency. So comparison point of view. Okay, the transformer which are used in the transformer which is used in the electronic device. If you take any the electronic device like tape recorder, converters and any electronic device, suppose these transformers are less in size as compared to the electrical power transformer. What is the reason here? The electrical operating frequency the 50 Hz, right? And electronic operating frequency the kilohertz. So that's why what we conclude here, the transformer which is used in, okay, which is the used in electronic device, okay, electronic device is less in size, okay, less in size the as compared to, okay, this is the as compared to electrical power transformer, okay, electrical power transformer. That means the transformer in substations, okay, substation here. So I think you have seen this transformer size is the very big as compared. So here transformer which is used in the electronic device is a very less in size as compared to electrical transformer. So frequency is also one of the factor to decide the size of the transformer. All of you got it my point? What I am telling you? Okay, అర్థమైందా అందరికి? అర్థమైందమ్మా? Very important for interviews and also competitive exams, GATE, ESE, Transco, Genco, railways, okay, all type of exams. మీకు ఇవి టెక్స్ట్ బుక్స్ లో ఉండవు. Okay, if you listen my class you will get all these type of questions. Okay, all of you got it? Everyone, you must respond in the chat box. Ram Sundar, very good, very good. Nageshwar, Sham Sundar, okay. Bharat, Rajkumar, very good. Okay. Replay past. మీరు ఎంత రిప్లై పాస్ట్ ఇస్తే we can discuss more. We don't want to waste our time. Okay, past ఇవ్వాలా replay. Josna, very good, very good. Okay, if you got it, then you can mention like thumbs up symbol or SR, then I know what is going on in your mind. Yes, yes. Okay, so now let us discuss one more observations from the EMF equation or other question. There is a question here. Okay, can you answer this question? All of you answer it. If 100 kVA USA made transformer is used in India, okay, used in India, then the maximum allowable kVA rating of transformer would be, okay, this is our question. So option A is given 100 kVA, 83.3 kVA, 50 kVA can't be operated. Can't be operated. Okay, now answer it, all of you. Do it pause. Akshay given D maybe. Why? All are given D. Okay. Okay. So to answer this question, okay, to answer this type of question, so we need some discussion. So that is a, so what is the relation between, okay, I will answer that question. See, okay. So if we know this relation, we can answer that question. So just I'm giving that question to know whether you can answer or not. So first one, what is the relation between, okay, kVA rating of transformer and also frequency of the transformer? Okay, if we know this, we can answer that question. Okay, clear point. So first one here, the power rating of the transformer. See all of you here, power, the rating of transformer, okay, rating of transformer is measured in, okay, measured in the volt amperes, okay, that is volt amperes or the kilovolt amperes, okay, or, so that is the volt amperes, kilovolt amperes or megavolt amperes. Got it point? So volt amperes means voltage rating multiplied by current rating. So therefore you can write kVA rating of transformer. Okay, this is the kVA, the rating of transformer, the is equal to in the secondary side parameter. So it is a E2 I2, okay, E2 I2 or E1 I1. Power remains same. So now at this point, okay, here, okay, at this point, so here is a kVA rating of transformer. Okay, we can write, okay, kVA rating of transformer directly proportional to the induced EMF. So this is at what point during the designing, okay, during, so designing the kVA rating, okay, directly proportional to induced EMF. So about this load current, okay, we don't know, okay, we don't know, okay, don't know the about the load current. Got it point? So about load current at the time of the designing, okay, at the time of designing here, so that it is treated as at the time of designing, so it is treated as a constant during the design, but it is a variable during operation of the transformer. So now during the designing can write kV rating of transformer directly proportional to the E2. So let us assume this is the equation 1. So here we know that here EMF induced in the secondary winding, the E2 is equal to 4.445 maximum, the Fn1 here. So from this equation, E2 directly proportional to the frequency. Okay, flux is a constant, number of turns is also some finite values here. So from this, let us assume it is a equation 2 here. So from the equations 1 and 2, okay, 1 and 2, so we get that is the kVA rating of transformer. Okay, kVA, the rating of transformer, so directly proportional to frequency of the transformer. So this is also one more relation. So in the transformers here, this can be obtained from what, which equation? EMF equation of the transformers. So size of the transformer is inversely proportional to the frequency, whereas kVA rating of transformer is directly proportional to frequency. Got it point? So all of it clear point. So why we have to take this is a considered as a constant. During the designing, we don't know about how much amount of current flow, whether it is a 100 amps, 200 amps, 200. When load is connected, then we know the current. But during the designing, we don't know that load current. That's why it is treated as a constant. So during the designing, kVA rating of transformer directly proportional to the induced EMF, and induced EMF is directly proportional to frequency. So compare these two equations, you can get kVA rating of transformer directly proportional to frequency of the transformer. Okay. Okay, all of it clear? Yes. Bhargav, you have given correct answer. We will discuss that question later. What is the relation between kVA rating and frequency of the transformer? That is, the kVA rating is directly proportional to the frequency, whereas size of the transformer is inversely proportional to frequency. Okay. Now we will discuss another question. Okay, this question also asked in the interviews many times. You can paste this question in any interviews also. Why transformer power rating mentioned in the kVA and in not in kilowatts? Or this kVA in the sense, so that is the apparent power. Okay, it is, so power it is a apparent power. Okay, kW in the sense it is a active power. Sometimes we have a question, why power rating of the transformer mentioned in the apparent power but not in the active power. So this is the question. Okay, anybody got it? Anybody can answer this question? Why transformer rating mentioned in the kVA? Suppose you can take any transformer, 100 kVA, 200 kVA, 300 kVA, 1 kVA, 5 kVA, like you will get this type of transformer ratings. So what is the reason behind this to mention the kVA? Why not it is the kilowatts? Why not it is a active power? Copper loss. Okay. Independent of power factor. Bharat. Right, Bharat. You have given correct one. Suppose listen. So that is a power is equal to active power of the transformer. Active power output of the transformer. Power output. So that is equal to, so here the V2 I2 cos theta 2. Okay, EMF induced in the secondary winding and secondary current, and also this is, so it is cos theta 2 in the sense it is called as a load power factor. Got it point? And it is a EMF induced in the secondary winding, or if you take terminal voltage V2 also, both are same. So voltage rating of the transformer. Okay, this is the voltage rating of transformer, and this one is a the rated voltage, and it is also the rated current of transformer. Okay, current of the transformer here. So in transformer, okay, in the transformer, how many losses are there? Actually, the rating is mentioned. Rating of any electrical machine is designed based on the temperature rise. That means losses of the transformer. So how many losses are there majorly in the transformer? There are only two losses. One is a copper losses and the iron losses. Copper loss depends on the current rating of the transformer and iron loss depends on the voltage rating of the transformer. And what about this power factor? Okay, this power factor here. So what we conclude here, the rating of any electrical machine. Okay, don't write, listen. Rating of any electrical machine, okay, any electrical machine is designed based on, okay, this is the design based on temperature rise, based on the temperature rise. So that means losses of transformer. So that means a losses means power being wasted, the power wasted in the form of heat due to temperature rise. So that is called as a losses. So in transformer, so what are the losses here? So in transformer there are two types of the losses. Okay, there are two type of losses here. So such as, what are the losses here? So one is a the such as, so one is that is iron loss of the transformer, okay, and second one is the copper loss of the transformer here. So this iron loss depends on, okay, which depends on the V rating, okay, V rating of the transformer. And what about the copper loss? So this copper loss depends on, okay, depends on the I rating of transformer. And question is, what about power factor? Okay, what about, okay, what about load power factor? Okay, that is, what about load power factor? So that means manufacturer doesn't know about the load power factor. So that's why E is considered highest power factor of the load. So which is the highest power factor of the load? So that is a unity is the highest power factor of the load. I repeat once again, see. So this manufacturer, okay, this is the manufacturer. So that is the don't know about load power factor. So do manufacturer, so doesn't know, okay, this doesn't know about load power factor, okay, about the load power factor. So might be connected, it may be connected, okay, connected the connected zero point 0.8 power factors, okay, it is a 0.8 power factor or the unity power factor or other one the 0.2 power factors like. So E was considered, okay, E was the consider highest power factor of the load, okay, that is highest power factor of load, power factor of the load. That means, so that is a 1 unity power factor of the load. So if power factor is equal to 1, okay, if power factor is equal to 1, so then what will happen here? Active power will become, the which one? The will become apparent power, apparent power here. So that it is measured, okay, so the it is measured in the here, measured the in kVA, okay, in the kVA or yeah, MVA or the VA, okay, volt amperes or megavolt amperes or kilovolt ampere here. So this is the exactly reason why transformer power rating mentioned in the kVA. I repeat once again, listen. The rating of any electrical machine designed based on the temperature rise. That means losses. In transformer, there are two type of the losses, the such as iron losses and copper losses. So iron loss depends on voltage rating of the transformer, whereas copper loss depends on current rating of the transformer. And what about this load power factor? Manufacturer doesn't know about the load power factor. So during the designing, okay, this is a that during the design. So it may be connected 0.8 unity power factor or 0.2. So he was considered highest power factor of the load, that is the unity. So if power factor is equal to 1, then active power output, okay, this active power output of the transformer will become apparent power. So it is measured in kVA or MVA or volt amperes. So this is the reason why transformer is power rating mentioned in kVA, why not in the kilowatts. Okay, all of it clear now? Very important question in the Vivas, interviews, okay, and competitive exams. Very good. Some people are given correct answers. Nageshwar, you written correct. Very good. Okay. Very good. Very good. Sham Sundar. Okay. So now we can answer this question. If 100 kVA US made transformer is used in India, then maximum permissible or maximum allowable kVA rating of transformer would be maximum permissible or maximum allowable kVA rating of transformer would be. Okay, answer now. What is the relation between kVA rating of transformer and frequency of the transformer? Here option A is given 100 kVA, 83 kVA, 50 kVA and can't be operated. Okay, here designing frequency. It is the which one here? ESE made. So here this is a designing frequency of the transformer. Okay, designing frequency of the transformer. Frequency of transformer. So that is equal to 60 hertz. Okay, what is the reason? So it is made with the USA, right? It is made in USA. So that's why it is a designing frequency. And operating frequency here, what is the operating frequency of the transformer? Frequency of the transformer, the 50 hertz. So why? Because it is operated in India. So that's why in India operating frequency is a 50 hertz. Got it? So now always to operate any electrical machine, okay, this is a very important factor. So to operate, okay, this is the to operate any electrical machine, okay, electrical machine. So here operating value should be less than the designing values here. Operate any electrical machine. So that is operating frequency or any electrical machine or transformer. So that is operating frequency, okay, should be less than the designing frequency, okay, designing frequency. So comparison point of view, see, operating frequency is the 50 hertz and designing frequency is 60 hertz. So that option D is not correct. Okay, we can operate in India. ESA made transformer can be operated in India, but at what kVA rating? Is it operated 100 kVA or is it operated other than the 100 kVA? So we cannot operate the rated kVA here. So therefore, the what is the relation? Therefore, kVA rating of transformer directly proportional to the frequency of the transformers. Got it? So now this is a kVA rating the in India divided by, okay, divided by the kVA rating in USA. So is equal to the frequency in India divided by frequency in USA. So that is equal to kVA rating in India equal to, so now simplify, So that is a 100 into, so 50 divided by 60. So by simplification, it is equal to 83.3 kVA. So this is called, okay, this is a allowable kVA rating. Okay, allowable the kVA rating in India. Okay, India here. So that means we cannot operate up to 100 kV. We can operate the USA may transfer in India with the less than the rated kVA. Okay, that is the value is, so that is the per 100 kVA transformer we can operate 83 points. Okay, 3% kVA rating, rated kVA of transformers. Okay, all of it clear now? What is the answer for this question? Very good. All are given B. So answer for this question is 83.3 kV. Now, now answer this question. Another one. If 100 kVA India made transformer is used in USA, then maximum allowable kVA rating of transformer would be. Okay. If 100 kVA India made transformer is used in the USA, okay, used in USA, then maximum allowable kVA rating of transformer would be. Now answer this question. Okay. First tell me what is the designing frequency in this question. Designing frequency. Designing frequency. Bharat given option C. Nageshwar Srinivas given option D. Okay, Nageshwar given option D. Very good, very good. First, what is the designing frequency? Tell me this question. Designing frequency is, Raju, you given 120 kVA. First, tell me what is the designing frequency for this question. 50, right? So here is a designing frequency is equal to designing frequency of the transformer. Okay, so that is a 50 hertz. Why? Because it is made in, so it is a the made in India. Okay, made in India. So that's why it is the designing frequency. And what is the operating frequency of the transformer? Operating frequency. Okay, here I have given always desirable here, operating frequency less than or equal to designing frequency, less than or equal. So not more than, not much greater than the this is a designing frequency. So now here is a designing frequency the 50 hertz, operating frequency the 60 hertz. Okay, it is operated in USA, right? Okay, USA here. So now is it possible? Okay, here if any electrical machine is operated above its rated values, okay, very high amount of losses can be developed in the machine which may damage the electrical machine. Okay, that's why that cannot be operated here. So that is a it is the designing frequency or operating frequency greater than the designing frequency. So okay, so practically it cannot be operated, practically it cannot be, okay, can't be operated. Got it point? So practically it can't be operated, but theoretically you can say, but practical cases you can be operated. Even though it is operated, then what will happen? Very large amount of the losses comes in the transformer due to the temperature rise, which may damage entire transformers, okay, which is undesirable. Okay, what is the answer for this question? Option D is a correct. The reason is operating frequencies are greater than the designing frequency. So practically it can't be operated. Okay, clear? So now let us move another. Yeah. Okay. Next, one more observations, that is a the relation between maximum flux density of the transformer core and V by F ratio. Relation between maximum flux density. Okay, here in this case it is a B maximum flux density. B maximum is the maximum flux density. Let B maximum in the sense maximum flux density of the transformer core. Density of transformer core. So next here V1 by F ratio. Okay, V1 in the sense supply voltage or apply voltage of transformer, and F is a supply frequency of the transformer. Supply frequency of transformer. Frequency of transformer. So now tell me, what is the relation between maximum flux density of the transformer core and V by F ratio? This is also very important relation to answer the question. Questions of the transformer. Okay, most of the questions in the operating side you can answer by using this relation. B maximum proportional to, okay, sin was given that B maximum directly proportional to B by F ratio. How do we get this relation? So this relation also can be obtained by using EMF equation of the transformer. See all of you. So we know here we know that P maximum or EMF induced in the primary winding of transformer E1 equal to 4.44 B maximum AN FN1. Okay, FN1 here. So from this relation, okay, here this is the size of the transformer. Okay, AN is the size of the transformer. Okay, size of transformer, right? So next N1 is a number of tons. Okay, here is number of tons in primary winding of transformers. So now tell me this question, is it possible to change the size of the transformer during operation? Are you getting my question? Is it possible to change the number of the tons during operation or working of the transformer? Is it possible to change the size of the transformer during working of the transformer? Is it possible? Is it possible to change the size and number of tons during operation or working of the transformer? Okay, mention in the comment box. Past replace. No, sir. Very good. Very good, Nageshwar. Very good. Not possible. Okay, Bharat, not possible. Right. You have to respond immediately. Past Vivala replay. Very good, very good. Not possible. Bharat, very good. Okay, మీరు ఎంత పాస్ట్ ఇస్తే మనం we can discuss more. Okay, so what we conclude here, size ను మనం వర్కింగ్ దగ్గర చేంజ్ చేయలేం. ఓకే, am I right? Similar way, టన్స్ కూడా నెంబర్ ఆఫ్ టన్స్ ఇన్ ద ప్రైమరీ వైండింగ్ అండ్ సెకండరీ వైండింగ్ టన్స్ కూడా వర్కింగ్ కండిషన్స్ దగ్గర చేంజ్ చేయలేం. ఓన్లీ we can change these two parameters during designing of the transformer. So therefore, what we conclude here, size of the transformer, okay, during operation, okay, this is the AN and N, okay, this is the, so AN number of size of the transformer core and number of the turns N1, okay, are fixed at the time of the designing, are fixed the at the time of, okay, at the time of the designing of the transformer, okay, designing, and treated as, okay, this is the, and the treated as, okay, as constant during operations, okay, constant, so during operation of transformers, all of you in mind. So AN and N1 are fixed at the time of designing and treated as a constant during operation of transformer, okay. So from this way, so do therefore, so if remove the all constant from this equation, so then what will happen during operation of transformer, the during the operation of transformer, so here E1 directly proportional to, I am removing all the constant, so that's why B maximum, okay, multiplied by the frequency of the transformer. So from this relation you can write B maximum directly proportional to E1 by F, okay, E1 by F. So when E1 is a directly proportional to the applied voltage V1 by F. So therefore we can write the maximum flux density in the transformer directly proportional to supply voltage and inversely proportional to supply frequency. So B maximum is directly proportional to V1 by F ratio. This is the very important relation to answer the questions based on the EMF equation, based on the losses, okay, based on the testing, all the okay, there. This is a very important relation if question is given about operating side, okay. So that's why this is valid only, so during operation of the transformer, okay, during operation of transformer only, but not in the designing side. So during the operation, maximum flux density directly proportional to V1 by F ratio. Okay, all of it clear now? N can be adjusted by tap changer. That is a, so you can provide the tapping, but it is an additional condition, not on the every transformer, right? That is a special feature. Tap changing అనేది, that is tap changing అనేది మనం స్పెషల్ గా ప్రొవైడ్ చేయాలి, కానీ ప్రతి ట్రాన్స్ఫార్మర్ లో జనరలైజ్డ్ స్టేట్మెంట్ కాదు కదా అది. టర్న్స్ చేంజ్ చేసి ట్యాప్ చేంజ్ చేస్తే, కానీ అది ప్రతి ట్రాన్స్ఫార్మర్ కాదు. నువ్వు స్పెషల్ గా ట్రాన్స్ఫార్మర్ వైండింగ్ నువ్వు ట్యాప్స్ ప్రొవైడ్ చేసి డిజైన్ చేస్తే నీకు ట్యాప్ చేంజింగ్ అని వస్తుంది. ఓకే, గుడ్. Okay, so now let us solve one question based on this equation. Okay, now solve this question, all of you. If applied voltage of the transformer is increased by 50%, while frequency is reduced by 50%, then core flux density will become option A 3 times, 3 by 4 times, 1 by 3 times, remain same. Okay. So this question actually we are operating the transformer, so that we can answer this question during the condition of operating. So that's why here what is the question is given initially V11 is equal to, okay, case 1 I am taking, applied the voltage in the case 1 So that is equal to V amount of the volts. And frequency F1 is equal to F edges here. So at this condition, flux density is equal to B maximum 1. Okay. So now case 2, we are operating the transformer by reducing the voltage, by increase the voltage by 50%. 50% means 150%. So that we will get V12 is equal to 1.5 times of the V11. Okay, V11. So now similarly, this is equal to 1.5 times of the V. Now similar, this is the F2 is equal to reduced by 50%. So reduced by 50% in per unit value is equal to 0.5 times of the F1. So therefore it is equal to 0.5 times of F. So now in this condition, what is the maximum value of the flux density? So this is about the question. Okay, case 1 and case 2. So during operation, we know that, so that is a during operation of the transformer. So during operation of transformer, so what will happen? So this B maximum directly proportional to, okay, directly proportional to, so V1 by F ratio. Okay, V1 by F ratio here. So this is, you can write B maximum 2 is equal to, or B maximum 2 by B maximum 1, B maximum 1. So into, it is equal to directly proportional. So that it is a V12 by V11 into frequency the inversely proportional. So that you can write F1 by F2. Okay. So now simplify here. Now substitute all the values of given the in this equation. B maximum 1 is equal to B maximum. Okay. So this is the B maximum 1 only, and V12 is equal to 1.5 times of the V divided by V. So into F1 is equal to, okay, F1 is a frequency F, and F2 is equal to 0.5 times of the F. So now here simplify these. Okay, V will be the cancelled out, F will be the cancelled out. So remaining is equal to 1.5 and 0.5. So therefore B maximum 2 is equal to, so that is a 3 times of the B maximum 1. So what is the answer for this question? So this is a option A is a correct. Okay. Very good. All are given option A. So this is the today's class. Tomorrow we have a questions. Okay, చాలా questions ఉన్నాయి EMF equations పైన. Okay, నియర్లీ ఒక 20 questions దగ్గర ఉన్నాయి. ప్రీవియస్ గేట్, ఐఏఎస్, ట్రాన్స్కో, జెన్కో, ఆల్ క్వశ్చన్స్. నేను EMF equations పైన ఎన్ని పాసిబిలిటీ క్వశ్చన్స్ ఉన్నావో, ఎన్ని పాసిబిలిటీ క్వశ్చన్స్ అడుగుతారో, ఇవన్నీ కూడా నేను రేపు డిస్కస్ చేస్తాను మీ దగ్గర. ఈరోజు మీకేం చెప్పాను? ఆల్ ద అబ్జర్వేషన్స్. ఒక డెరివేషన్ ఒకటే ఇంపార్టెంట్ కాదు, behind the derivation there are some observation or possible questions from that EMF equation. రేపు మనం ఇదే EMF equation పైన క్వశ్చన్స్ ఎలా ఉన్నాయి, ప్రీవియస్ గేట్ క్వశ్చన్స్ ఎలా ఉన్నాయి, తర్వాత ప్రీవియస్ ఐఏఎస్ క్వశ్చన్స్ ఎలా ఉన్నాయి, నెక్స్ట్ వన్ ట్రాన్స్కో క్వశ్చన్, జెన్కో క్వశ్చన్. ఓకే, కొన్ని క్వశ్చన్స్ ఓకే ఎక్స్పెక్టెడ్ క్వశ్చన్స్ అంటే ఇలాంటి క్వశ్చన్స్ నెక్స్ట్ గేట్ 2021 లో కానీ 22 లో కానీ అలాంటి క్వశ్చన్స్ రావచ్చు. అవి వీ కెన్ ఎక్స్పెక్ట్ that type of questions also. All the questions we'll discuss tomorrow. Okay, don't miss the class tomorrow. It's a very useful to you for all your competitive exams. Am I right? Okay. And okay, this is the Creatrix official channel. So you can join in the channel to get all benefits, or also you can get any updates from the Creatrix also you can get. And this is the Unacademy Gate Telugu Telegram channel. Okay, here you will get all class PDF notes. Okay, class PDF announcements. Okay, announcements, and also any assignments or class PDF. And this one is the channels point of view. It has the India's #1 study channels. So one is a Creatrix Gate, Unacademy Gate, Unacademy Civil, Unacademy Gate Telugu, and SSC, the JE, computer science, questions, electrical junction, and engineering foundation, and also engineering patashala. So what about our channels? Every day I'm telling you. So this lifetime of our channel depends upon you people only. You should share the channel to the maximum people. So first like, okay, this is a very important thing. Like, share, and subscribe. Okay, subscribe this channel. ఓకే ఈ మంత్ ఎండింగ్ వరకు ఎన్ని సబ్స్క్రైబర్ అనేది ఎంత వస్తుందనే మీ పైన డిపెండ్ అయి ఉంటుంది. సో మాక్సిమం పీపుల్ షేర్ చేయండి, లైక్ చేయండి అండ్ సబ్స్క్రైబ్ చేయండి. ఓకే, గట్ ఇట్. ఐ లవ్ యూ. థ్యాంక్ యూ. లైక్, షేర్ అండ్ దిస్ ఇద లైక్ చేయండి, షేర్ చేయాలా, సబ్స్క్రైబ్ చేయండి. థ్యాంక్ యూ వెరీ మచ్. విల్ మీట్ టుమారో. సో యాక్చువల్లీ నేను స్పెషల్ క్లాసు ఎలక్ట్రికల్ మిషన్స్ లో ఎన్ని లాస్ అయితే మీకు యూజ్ అవుతాయి అంటే ఎలక్ట్రికల్ మిషన్స్ నేర్చుకోవడానికి మీకు ఏం లాస్ కావాలా, లైక్ పారడేస్ లాస్, తర్వాత లెన్స్ లా, ఎఫ్ఆర్ఆర్, ఎఫ్ఎల్ఆర్, ఓకే, పోర్స్ లా, ఇవన్నీ కూడా కొన్ని లాస్ ఉన్నాయి. ఒక 10 లాస్ ఉంటాయి. ఆ లాస్ పైన నేను మీకు స్పెషల్ క్లాస్ తీసుకోవాలనుకుంటున్నాను. సో ద స్పెషల్ క్లాస్, ఓకే, దట్ ఈస్ ద స్పెషల్ క్లాస్ అనేది యూట్యూబ్ లో కాకుండా అన్అకాడమీ లెర్నింగ్ యాప్ లో ఉంటుంది. సో ఈ అన్అకాడమీ లెర్నింగ్ యాప్ లో మీరు ఈ క్లాస్ ను ఫ్రీగానే యాక్సెస్ చేయొచ్చు. కాకపోతే మీ ఫోన్ లో ఈ యాప్ ఇన్స్టాల్ చేసుకోవాలి. ఓకే, అన్అకాడమీ లెర్నింగ్ యాప్. సో మీరు ఇందులో మీకు యూజ్ అయ్యేది ఎలక్ట్రికల్ మిషన్ నేర్చుకోవడానికి యూజ్ అయ్యే ఆల్ లాస్, ఒక ఆల్ దట్ ఇస్ ద రిక్వైర్డ్ లాస్ టాపిక్ ఈజ్ ఏ సో రిక్వైర్డ్ లాస్ టు లెర్న్ ఎలక్ట్రికల్ మిషన్స్ కాన్సెప్ట్స్. ఓకే, దిస్ ఇస్ అవర్ టాపిక్. సో మనం అన్ని లాస్ డిస్కస్ చేద్దాం. ఓకే, ఇక్కడ సో మీరు దానికి స్పెషల్ క్లాస్ ఏంటంటే మీకు ప్రీ యాక్సెస్ ఉంటాయి. మీరు చేయవలసింది అన్అకాడమీ, ఓకే, అన్అకాడమీ లెర్నింగ్ యాప్ మీ ఫోన్ లో ఇన్స్టాల్ చేసుకోండి, ఆ ల్యాప్టాప్ లో ఇన్స్టాల్ చేసుకోండి. సో ఫ్రమ్ ద గూగుల్ స్టోర్ ఆర్ ప్లే స్టోర్. సో దిస్ ఈజ్ అవర్ టాపిక్. ఓకే, మీకు కన్వీనియంట్ టైం చెప్తే సండే రోజు నేను ప్లాన్ చేస్తాను. సండే మీ కన్వీనియంట్ టైం చెప్పండి. సండే ఎనీబడి, మీరు అందరు అటెండ్ కావాలా. మీరు ఈ లాస్ అని నేర్చుకున్నా అనుకోండి, ఎలక్ట్రికల్ మిషన్ చాలా ఈజీ ఉంటుంది. నువ్వు చదివేటప్పుడు కాంప్లికేటెడ్ గా ఉండదు. రిక్వైర్డ్ లాస్ టు లెర్న్ ఎలక్ట్రికల్ మిషన్ కాన్సెప్ట్స్, దట్ ఈస్ అవర్ టాపిక్. ఓకే, షేర్ లింక్ చేయండి సార్ పీడిఎఫ్. ఓకే, షూర్, ఐ విల్ షేర్ ఇట్. సుందర్, ఐ విల్ షేర్ ఇట్. ఓకే, మీ కన్వెంట్ టైం మెన్షన్ చేయండి చాట్ బాక్స్ లో. సండే రోజు నేను ప్లాన్ చేస్తాను. ఓకే సార్, 10 AM. ఓకే ఓకే, మార్నింగ్ 10. ఓకే, 10 to 12. ఓకే, గుడ్. నేను కూడా అదే అనుకున్నాను, 10 to 12 అని. మీ కన్వీనియంట్ ఉంటుందా లేదా అని ఒకసారి అడిగాను. మార్నింగ్, ఓకే ఓకే, రైట్. రమేష్, ఐ థింక్ యు ఆర్ లేట్. ఓకే, సండే కదా, 3 to 4 అంటే ఈవినింగ్ ఎందుకు, సండే మార్నింగ్ క్లాస్ తీసుకుందాం, స్పెషల్ క్లాస్ మిషన్స్ లో ఎలక్ట్రికల్ లాస్ అని నేర్చుకొని. సో ఆఫ్టర్నూన్ ఫ్రీ ఉంటుంది మీకు. ఓకే, sorry, I will decide the time today and I will inform you tomorrow class. Okay, thank you very much. Thank you all of you. అండ్ మీరు రేపటి క్లాస్ మిస్ కాకండి. రేపటి క్లాస్ మిస్ అయితే మీరు చాలా మిస్ అయినట్టు, ఇక చాలా క్వశ్చన్స్ మిస్ అయినట్టు. లైవ్ లో క్లాస్ వినడం చాలా వేరే ఉంటుంది, రికార్డెడ్ క్లాస్ వినడం వేరే ఉంటుంది. సో రేపు క్లాసు అన్ని ప్రాబ్లమ్స్, అన్ని పాసిబుల్ క్వశ్చన్స్ బేస్డ్ ఆన్ ద ఈఎంఎఫ్ ఈక్వేషన్ డిస్కస్ చేద్దాం. ఓకే, థ్యాంక్ యూ వెరీ మచ్.